So this next panel is just called Projective Urban Air Mobility. And we are going to hear from three designers, Giovanni de Niederhäusern, who's a trained architect, Fiona McDermott, who will be joining us remotely from Dublin, and Immony Men, who's an artist and creative technologist. The panel is organized around scales of operation and proceeds from the idea that the drone is a kind of class of object, and that actually different morphologies produce different possibilities and scales of action. And so Giovanni is going to speak about a kind of retooling of 20th century infrastructure. Fiona is going to be speaking about some of her projective work around drones as mobile communication networks, and Immony will be speaking about drones and the roles that they can play within a participatory design process. So just for brevity, I'm maybe going to just quickly introduce all three of you, and then you can run the show. I guess we'll reserve questions for all three panelists until the end. Giovanni graduated in engineering and architecture in 2008, having collaborated with a number of Italian architectural practices since 2006, including Iona Giovanni, associate in Bologna. In 2009, he joined the MIT Senseable City Laboratory as a research affiliate. In 2009, he began collaborating with Carlo Ratti Associates as a designer and project manager. In 2014, he earned an MBA from the Luce Business School in Rome. He's also been a lecturer at Italian universities such as the Politico di Torino and Luna Bologna. In 2017, he became a CEO at Carlo Ratti Associates, in charge of opening CRA's New York office. Fiona McDermott is a PhD candidate at Connect, the Research Centre for Future Communications and Networks at Trinity College Dublin in Ireland, and formerly a Fulbright visiting scholar at the School of Media Studies, the New School in New York City. Her research focuses on networked forms of urbanism and the ways in which Internet of Things and remote sensing technologies are restructuring urban practices. In addition to governance and design, she holds a Master's of Architecture and Urban Design from the Bartlett School of Architecture, University College London. And Immony Men is an artist, educator, and community-based researcher. He's an assistant professor in the Digital Futures program at OCAD University and the co-director of the Public Visualization Lab. He has completed an MFA in visual art at the University of Windsor. He also completed an MA in communications and media studies at McMaster University. As a researcher, Immony has been involved in a variety of projects that incorporate drone videography, photogrammetry, interactive technology, and time-based media. As an artist, he has exhibited nationally and internationally and has been awarded municipal, provincial, and federal funding in support of his work. Men's practice takes the form of interactive installations, interdisciplinary performances, social artworks, and community-based research projects. And he also shares a social art practice with his collaborator, Megan Broadhurst. He has exhibited widely, very widely. So I guess join me in welcoming Giovanni.
Well, good morning, everyone. I'm very pleased to be here with you today. First of all, thank you to the faculty for inviting me, and thank you for the Istituto Italiano di Cultura in Toronto for sponsoring my participation, and thank you for Simon for organizing everything. So I'll do a quick presentation, about 10-15 minutes, about three projects connected to drones. Two of them are actually about flying drones, but I wanted also to integrate a project about a floating drone technology that we're testing. But first, I would like to start with a little bit of vision, because for us as Carlo Ratti Associati, we are a design and innovation firm between Torino and in Italy and New York. For us, the vision is very important, and I think it's important for you also to better understand the context in which we develop these projects. The first project I wanted to, the vision, the first slide about the vision. I always start with this image of virtual reality back in 1995. At that time, it was a common belief that as the phone had killed the concept of distance, internet would have killed the concept of space. So to George Gilder, cities were just a leftover baggage of the industrial area, which means space doesn't have a meaning, it doesn't have a sense anymore. Well, actually, things turned in a very different way, as we know. I mean, everyone is here in a physical space to talk about drones. And this project, it's called Dubai Creek Harbor, and I always show this because it's one of the largest real estate intervention ever done in human history, as well as we know that China is currently building the same amount of urban fabric, the same amount as it was built by humanity. So space is still very important, and another data that support this comes from the United Nations Population Funds that since 2008 told us that more of the half of the worldwide population is living into cities, and this data is continuously growing. So what happened? It happened that digital technologies didn't kill the importance of physical space, but didn't leave it unaffected though. So a number of digital technologies are kind of layering the physical space, integrating with the physical space, providing new ways of working, living, interacting, and also understanding and managing cities in this case. And drones can be very much part of this physical and digital layer. I think they can even be like the next step, in the sense that, like, by themselves, given the fact they can move quickly in space, they can be an even more dynamic technology to, in real time and on demand, create new services at the city level. In the long term, this kind of Internet of Things vision for us will bring us to have every atom, every object, not every atom, to be a sensor and an actuator. And this will ultimately bring to a space that interact and react to people in real time based on their needs. So this is the vision within, in which lies our research. And within our vision, we developed 3 projects that I'm going to present to you. The first one is called Paint by Drone. The client in this case, funny enough, is a non-profit bank foundation. It's actually the second largest in Italy and one of the largest in Europe. And they came to us and said, we would like to develop a project in which, through technology, we can create contemporary culture. So especially in the periphery of a city like Torino, which is the city in which we are based and this foundation is based, we want to create an interaction between new emerging artists in neighborhoods and the city itself. So through drones, we developed this concept, which is called Paint by Drone, of drones that can paint on vertical surfaces, like kind of digital, digital and physical graffiti. Going through the I'll show you this video first, which is easier. So basically, we integrated spray cans into a very simple quadricopter, and we had to develop. This is the hardest part: to develop a technology to locate in real time the drone onto the facade. As you possibly know, there are 3 main technologies to do this. The first one is the ultra-wideband, which is the one that we use in this video. The second one is the computer vision, which is actually more accurate. You will see it in the next slide. And the third one is laser. So we started with the ultra-wideband technology. And I go back to the previous slide. Yeah. So basically, creating on, you see it on your right, on a scaffolding structure, installing sensors to locate the drones, and onto the drones, basically, we integrated this painting system and a few very light technologies for positioning, anti-collision, and a small computer, and we started testing it. So the first result with the ultra-wideband, they weren't the best. As you had seen in this video, we wanted to reach a very high level of quality because obviously we had to represent a shared effort from different artists in the city. And in the end, the whole thing obviously was managed through a digital platform. In the end, we decided to experiment with computer vision. And with computer vision, we were able to reach this level of accuracy that, as you see, is, I mean, this obviously goes like, the video goes faster than reality, but it's very accurate, allows you to write not just wireframe drawings, but also, you know, full colors. And through the use of different drones, we are also able to do this kind of digital physical graffitis in cities in different colors. So the experience, as I was saying, is that through a digital platform that you had seen in the previous slide, different artists from a specific neighborhood in Torino will be able to upload their drawings. The drawings all together will compose a unique graffito that will be displayed onto empty facades in the city. So to create an engagement between people, like citizens, the city itself, and to leave a legacy also in the periphery of Torino, which is very well known as a very gray city. So we wanted also to bring some color. We're also reproposing the project in other conditions. Obviously, our ambition is to be able to use this technology on very large surfaces. And in this case, for example, we are proposing this in a very large construction site in Rome, in which the idea is to use the textile applied for covering the scaffoldings as a canvas for creating this continuously evolving large digital painting at the city level. The second project I wanted to talk to you about goes more into the field of urban infrastructures. So in this case, the client and the partner for this project was ANAS. ANAS is actually the leading company for managing highways in Italy. They're public, and they manage about 25,000 kilometers of highways in the country. And they have a budget of about 30 million to create a smart infrastructure on 10% of these highways, which is about 2,500 kilometers of highways. It was a nice research because they started thinking about completely redoing the highway infrastructure, and we said, well, through technologies, I mean, we can actually apply kind of a digital layer that will be able not to redo completely the infrastructure, but to make it smarter with a minimum and very light intervention. In this case, again, we wanted to use drones for three main purposes. So the first one was, I mean, this is easy to understand, to better monitor the situation on the highways. It's true that through Google and other systems, we can understand whether there's a traffic jam or something, but, ANAS needs, wanted to know in real time exactly what happened, especially if there's some kind of, accident or major event related to weather conditions. And so drones obviously are represent a very flexible infrastructure to monitor what happened in the street, but second, also to bring first aid to drivers in case of accidents or major injury. They are also able, and this is the third point, to continuously monitor the status of the infrastructure itself. Especially in some points in which it's not so easy to access or continuously access. I'm thinking, for example, about tunnel or, viaducts or bridges and so on. I'm sure you're familiar with what happened in August in Italy, in Genova, when an important infrastructure, a bridge collapsed from one moment to the other. And so there is, in the whole country, there is now a lot of attention to understanding how we can continuously and in real time monitor these kind of old infrastructures so that this kind of accident doesn't happen anymore. So here you see some renderings. Obviously, I mean, if we have to have drones to cover, 2,500 kilometers of infrastructure, we need to have some recharging platforms. And so starting from this, we created this system of poles. We call them smart poles that have three functions again. So the first function is to be a recharging platform for the drone. And the second function is to integrate a number of very sophisticated sensors related mostly to traffic, weather condition, and pollution. And third, to be able also to provide information to the drivers about obviously the status of mobility in the highway itself. So this is still a design project, but as I said, there is a budget, and we're moving forward on starting the development and the deployment of this technology on the highways in Italy. The third and last project I'm going to present to you, it's again about infrastructure. That's why I put it in the end. And it's about drones, but not drones in like flying drones, but floating drones. Again, in this case, through the lab at MIT, we were working with the city of Amsterdam, understanding how we can improve mobility in the city. And the idea was, again, not to create very like new infrastructures from scratch, also because in a city like Amsterdam, you can't really build new streets. Or so we said, let's use the canals as a new way for a new tool for mobility, and also as an occasion to create new services to make the city more responsive to the actual need of the users. So we developed this concept of self-driving vessels. They're actually drones. They work as a quadricopter in the sense that, as you will see in the video, they have four propellers at the edges that allows the system to move very accurately in water. And we also applied the self-driving technology to this platform so that they can move themselves on their own in the canal system in Amsterdam. Why is it possible to use self-driving in this case, and it's not still very common to use it in streets? Well, it's actually very easy. When you move a self-driving vehicle in the water, then risks are way lower. Velocity is lower. Obviously, you don't have pedestrians, and platforms and boats. They used to bump into one into the other very frequently. So actually, the canal system in Amsterdam is a very good system to test the self-driving technology. Again, so what is this technology about? It's mostly about moving people, moving goods. We're actually thinking about using the service also for waste management purposes. And this is the game changer, I think. Thinking about a modular system, we can also think about building bridges or platform for very specific occasion or needs in the city. This is why we call this a non-demand infrastructure, because you can reconfigure it and move it accordingly to the actual need of the city in real time. Last two slides, this one is the first prototype that we did. So obviously it's a small-scale prototype. Sorry, it was not intended to have audio, but yeah, it's not bothering too much. And it works pretty well. We're now studying the system to make a very simple the platforms themselves to aggregate one with the other. And since the system is actually using LiDAR to move around the city, on time we actually understood that we could collect a number of data about the city itself to have this kind of real-time image of the city, which is a completely different perspective. Not sure if you're familiar with LiDAR. It's actually a radar that detects objects through a kind of a cloud of points, and is able to continuously update a different vision, a different image of the city in real time. We can obviously aggregate the whole data and add this unprecedented and unseen vision of the city. That's why these kind of technologies can also offer us new insights on the space we live in every day. These were the three projects, and thank you so much for your attention and again for having me here.
Next, we'll be hearing from Fiona. So first off, Giovanni, thank you so much. That was super interesting, and we'll have things to talk about at the end of the three presentations. Next, we're going to hear from Fiona McDermott, who is addressing us from Dublin. Hello, Fiona.
Hi there.
Thank you so much for joining us today.
Hi, is that Simon?
Yes.
Hi. Is my audio okay?
You're coming through clear.
Okay, great.
So please begin, and if you have some images, please use the screen share.
Let's just do start sharing. Can I ask, are we a little bit behind schedule, or?
Pardon me?
Are we a little bit behind schedule, or?
We started a little bit late, so I feel like just stick to your plan.
Okay, well, I'll try and keep it short as possible. Just let me know if the audio breaks up or if there's any difficulties in hearing me. Okay, and hopefully you can see my full screen. Yeah?
Coming through clear.
Okay, great. Okay, I'll get going then. Okay, so thanks, Simon, for the invitation. It's great to participate even remotely. I'm going to try and keep this really short, about 15 minutes, and I just want to acknowledge the feedback from colleagues of mine, Bart Skalkin, Linda Doyle, and other colleagues at Connect. So just to give you a little bit of context of where I'm coming from, I'm based at a research centre that's part of Trinity College in Dublin, and we do research around telecommunications and the development of networks. So there's both theoretical work and applied work, and we do a lot of work with industry partners. So I'm going to talk very briefly today about the application of UAVs to telecommunications. So one of our major research areas is looking at the idea of moving networks. So the idea of moving away from static fixed network infrastructures to nomadic or mobile infrastructures that are based on different modes of mobility. So trains, connected cars, and UAVs is kind of increasingly becoming a larger area of research within this field as well. At this stage, I should probably say, unlike a lot of my colleagues who are coming from computer science and engineering backgrounds, I'm not a computer scientist. So my own research looks at network technologies and how they interact with the materiality and politics of the city. I'm coming from kind of an urban design background. But one of the things that continually fascinates me working in this field of emerging technologies is the ideas that they're always new, and these are very new concepts, but at the same time, you constantly see this reoccurrence of concepts. So for me, the moving network has real parallels with these ideas that we've seen in architecture before. So this is Instant City from Archigram from 63, so it's like 50, 60 years old at this stage. And it's a concept that proposes this aerial technological objects that temporarily settles down within an existing environment, and it's delivering new services and superimposing new means of communications and information overlay onto kind of an existing community. So I always kind of like to remind the engineers of this kind of longer arc of aerial infrastructures on the move, or even if they are just kind of conceptual. But I'm also very interested in the different motivations and different value systems, say, behind speculative work like this, and maybe the more kind of utilitarian motivations behind the network infrastructure that we're doing today. So I'm going to talk very briefly about two areas that UAVs are being used or potentially used in telecoms. So, the first one is in the planning and research stage of telecoms infrastructure, and the second one is kind of in the actual deployment, so using UAVs as actual deciding for network infrastructure. So before I go into this, I want to take a step back and just to talk very briefly about the fundamental infrastructures to which cellular networks are deployed. So people will be familiar with these types of structures. They're macro base stations. They're normally at very high locations. You'll see in all sorts of different settings, from kind of rural to suburban to maybe an urban setting at a higher vantage point, and they have this coverage up to like 20 kilometers. And the other kind of very significant and becoming increasingly significant infrastructure is what we call small cell or micro cell base stations. So you find these on the side of buildings or disguised within existing street infrastructure, like traffic lights or street lamps. And these are becoming really, really important in terms of delivery capacity, and especially in dense environments like cities. So But with this kind of increased density, the planning and deployment of them is kind of increasingly difficult as well, as you can imagine, working within city environments versus working on a brownfield site. I think most people will understand the differences of that. But it's becoming this real kind of interesting race between traditional network operators like I guess, I don't know if you guys have AT&T or Verizon or Sprint, but you also have these new technology players like Facebook and Google, which are effectively infrastructure companies also, who are kind of racing to adopt new technologies and design cellular networks. So I'm going to talk about one example of kind of a small cell-based system and how UAVs are used for the planning of it. So this is Facebook's Telegraph. I don't know if anybody's familiar with this. I think they started it originally around 2015, 2016, and they're trialing it in San Jose. But it is effectively what they call fiber in the air. So if you think how fiber works, a fiber optic works underground, you have these like super efficient conduits that are delivering light streams. This is taking that concept and moving it up in the air. So they're using equipment that's attached to building facades and street furniture, and it receives these highly directional millimeter wave signals that require line of sight. So you'll see from the little animation there that all the equipment needs, so each of the, there's no obstruction between any of the signals. So that's really significant. But the planning and the planning and pre-deployment of these is usually problematic, given the kind of high density of it, the mesh topology, and the line of sight that's required. If we think about traditionally how telecommunication infrastructure was planned, it would have required things like site surveys, walking around the streets, manual inspections, kind of trying to identify installation sites, and then doing some very kind of sketchy estimations of radio wave propagation. So it's really slow, really arduous, really difficult to get good information. So what the UAVs are offering is this aerial perspective that allows for a capture. So this is LiDAR, 3D LiDAR capture taken by UAV that's being used to plan these networks. So you can see here an image capture of the location from an aerial perspective, and then what's afterwards is machine learning and computer vision that kind of classifies all of the assets or potential sites of deployment, and then they're isolated, and then this image actually shows that the blue lines show an analysis of the line of sight that I spoke about, this idea that you have to have point-to-point line of sight in order for these networks to operate. So ultimately, it's this kind of really big advancement in terms of reducing the time and making the process more accurate and comprehensive. So I guess that's just one example of how UAVs are becoming critical in the planning of telecom infrastructure. So the second area that I wanted to look at was actual UAVs being used in the deployment itself. And I guess I want to say straight out that infrastructure it sometimes moves anyway. So you can get broadband on a plane. Base stations are connected either to satellites above or to the ground below. And you also have similar things with ships that have base stations that they can move in and out of range. So it's not that you necessarily need a drone to have a moving infrastructure, but at the same time, they are being used to fly base stations into locations. So, and we're seeing real-world adoption of this in terms of connectivity to environments where fixed infrastructure is either too difficult to deploy or where infrastructure just isn't kind of economically viable. So maybe in rural areas. So this is Google's Project Loon, which people might be familiar with. It was deployed in the aftermath of Hurricane Katrina or Hurricane Maria in Puerto Rico, but it's also a project that they're developing further, and it's 20 miles in the air. It's an untethered loon to be used in remote areas where cell towers aren't economically feasible. And another version or another form of this is AT&T's Stellar. So it's a small helicopter design that hovers at 60 meters above the ground. And it's tethered, so it actually has a physical connection to the ground, to a ground station. And it covers 40 square meters, 40 square miles. So it's quite a wide range, like Loon as well. But they're kind of they're kind of designed to be kind of emergency or plug-in fixes. But on a more localized scale, there's also developments that are looking at deploying small cell kind of on a temporary basis in urban settings. So this is work being done by, it's a British mobile network operator called EE, and they're deploying small cells mounted onto blimps and UAVs for public events with like a high density of people, so sporting events or festivals. But this is one of the areas in academia that is also kind of gaining traction. So the idea of deploying UAVs, which carry small cells, to deliver wireless networks to users in urban environments for demanding for dealing with demand hotspots. So it's most of the work. My colleague Bart Stockin has just finished his PhD on this, and it's quite theoretical. So it's a lot of stochastic modelling, but he would argue that it kind of offers a lot of advantages over conventional terrestrial infrastructure. So it kind of has as a UAV, it has flexible positioning, so it can move in 3 dimensions, it can move in real time, and you have this high level of control and performance optimization. And also importantly for telecommunications, it has the aerial vantage, and it's more easy to establish the line of sight. And he would argue it's also faster and cheaper to deploy, but I would say there's kind of big questions around that. And one of the big limitations, of course, is kind of battery life. So it's still a big question as to whether there's ways of switching out the batteries automatically, but it's still kind of a question as to whether it's a more viable system than a fixed cell, it's something that's like a permanent infrastructure. So kind of as a summary then, I would say that as a tool for surveying and planning infrastructure deployment, especially in dense, complex environments, the UAVs and the aerial views afforded by them kind of offer this critical advantage. But in terms of UAVs for deploying infrastructure itself, still at the very early stages, and there's plenty of hurdles in terms of practicalities and battery life and regulation. So I guess the question kind of remains as to what degree telecoms will be delivered through permanent and fixed infrastructure, or to what degree they migrate towards flexible and responsive mobile infrastructure, as those envisaged by our program here. So that's me, I think. Thank you.
Thank you so much, Fiona. That was really excellent and definitely well paired with Giovanni's and pointing to a number of lines of conversation. We're going to hold questions until the end of the 3 presentations, and so next we're going to hear from Immony Men.
Hi, everyone. Thank you for coming today. Thank you so much, Simon, for organizing this event and inviting me. So I'm going to be extremely candid and very honest. So I'm going to disclose that I'm not a specialist in the area of drone photography, videography, or piloting. I must admit I'm an extremely reckless drone enthusiast. You can ask my partner if I'm a specialist of anything. It's making a mess, and perhaps that's like some form of critical design practice. So I'm currently the co-director of the Public Visualization Lab with Patricio De Villa, where we work alongside communities to represent and So I'm currently the co-director of the Public Visualization Lab with Patricio De Villa, where we work alongside communities to represent and communicate concerns around equity, social justice, the environment, and democratic participation. This art and design research lab employs visualization, curation, mapping, modeling, and storytelling through digital media. So PVL is interested in fostering cross-institutional partnerships with other universities and organizations to present events, publications, creative projects, and community-based research. So we work on projects with community partners and industrial collaborators to present university exhibitions, research projects, workshops, thematic programming, experiential learning opportunities, temporary skate park activations, public video installations, and social artworks. Some of these activities include research creation projects and capacity sharing with community partners through critical, participatory, and decolonizing practices with technology. We host a bunch of public workshops, lectures, and web resources on emerging technology as means of supporting community building, and we also diversify knowledge production through curatorial projects and artist/designer residencies. How do we use drones? Is this still going? Let's just roll this a bit. So I believe that the work that is being conducted within the lab is searching for a common experience between partners, stakeholders, and community members that unravel the social, economic, and political dimensions of reality, revealing cultural tensions, systems of power, tactics for liberation and resistance. So we apply aerial photography and videography to construct what Ziga Vertov coins as visual bond, which is the use of moving images and creative vision to include existing social and cultural relations to organize individuals, producing tactics and strategies that are related to a set of politics, as well as disseminate stories and experiences to an audience. As a research tool, we use aerial drones to explore the rapidly changing urban landscape of Toronto, specifically the gentrification of East Chinatown, as a relational platform to construct discursive spaces for skate park planning and development, and as a transmedia storytelling technique to investigate the lived experiences of Indigenous elders from Ipperwash. So I've chosen some examples of works that represent the different forms of inquiry. They're cultural, social, and political, that art practice can explore through the use of these aerial image, through this process of capturing aerial images. So the first project that I'm going to show you is titled Everything in Place. So in this multi-channel video installation by artists Patrick Cruz, Serena Lee, and Casey Messia, place is both inheritance and memory. So it holds a dual role in shifting ground, and it also holds colonial remnants. So marked by distinct geographies of Toronto's Asian communities, these works address the politics of space, diasporic tensions of tradition, racialization, and translation. So this exhibition was co-produced with the Modest Eyes Collective, and it was led by myself, Michael Tanaka, and supported by the Public Visualization Lab. So what you're seeing right here is you're seeing Serena Lee. She is a Chinese-Canadian artist. Her work layers cinema, performance, voice, image, and text to map a political grammar of harmony. And the work that she presented for Everything in Place was titled Needle to Sea Bottom. And it draws from Ido Sterl's concept of free-falling and the Chinese martial arts of Tai Chi Chuan. Lee explores the idea of balance not as a state but as a movement through inherited narratives of materialism, immigration, and animism in Toronto's gentrifying Leslieville and Broadview Chinatown. And at first, we started to explore these technologies that capture gesture and motion and we were trying to figure out how do we create an essay film using these technologies. And Serena invited me to fly this newly purchased drone in her grandfather's backyard. And again, I'm very reckless, and I flew it in her backyard, and from the images that from those images, I was able to apply a technique called photogrammetry. So photogrammetry is the input. It's the use of photographs to create a 3D model of a space or object or person. And aerial photogrammetry is when you use a drone to do that. So from the video footage that we captured, we were able to reconstruct this 3D image of her grandfather's backyard, and as well as her neighbor's backyard. And yeah, so this is building on that notion of materializing bodies, materializing spaces, and also cultural tensions that support data narratives. So we were able to experiment with what you're seeing is that 3D model of that backyard space with the motion capturing technique that was applied for the Tai Chi set that she choreographed. Okay, so that's everything in place. The next project that I'm going to talk about is community-based visualization and skate park planning. The overall goal of this project is to use data visualization and mapping practices as a platform to recontextualize public space by constructing a counter-argument for defensive architectural designs related to the activity of skateboarding. In result, it will construct a model for social art practice as a form of research. But this work will articulate a critical approach of how visualization and community engagement as a research and creation practice can respond to both civic and citizen inquiry. The primary goals of this project is to develop a theory of community-based research within a social art practice that includes the process of data collection, community outreach, and project making as a part of the creation process. It employs theories developed by creating a visualization and mapping project that rivals defensive architecture against skateboarding within Toronto by providing an alternative design typology that can be applied to municipal skate park planning. So I've worked with the TSC on this project, and what we've been doing is we've been addressing some of the issues that are coming up with the city directly in relation to DIY spaces. In 2016, the City of Toronto adopted the Toronto Skateboard Strategy, which had a series of different recommendations, from an increase of community engagement and skate park development to other recommendations. So I've been assisting them with advancing these plans and also working with DIY skate park groups. So this is where I met the Build for Bokuma, and the Build for Bokuma is a not-for-profit organization located in Toronto. Their mandate is to create multifunctional, skatable public structures. Their long-term goal is to develop a community-based skate park that commemorates the life of Canadian pro skater Justin Bokuma. The group is focused on fostering a long-lasting dialogue with the public and future generations of skaters by utilizing underdeveloped spaces in innovative and creative ways. And this demands for more places to skateboard, and we've worked together to integrate skateboarding within future developments, initiatives, and community-led activities within the City of Toronto. I met the group and through the several meetings with the Toronto Skateboard Committee, and they wanted to create a 3D representation or a model of one of their latest builds. And this particular build is at Black Creek, And in the past, they've had 3 or 4 different DIY skate park builds that have been demolished. And this one is still there, so they wanted to create a 3D model using photogrammetry, and we were able to do that. And the reason why I'm showing you this is we've been using these technological processes to create discursive spaces to talk about placemaking and the politics of space. Yeah. Yeah. So for me, like, drone videography, photogrammetry, and all these processes come together to create this form of public discourse, but also engage communities. So it's not a direct output of, or it doesn't contribute to a direct output. So what we're looking for is how do we use these techniques to create actual skatable spaces. So all this led to our relationship with the Bentway. And last summer, the Bentway and the Bill for Bokuma presented Sight, which is a summer-long celebration of skateboard arts and culture, which launched on June 30th. The opening weekend revealed a new art installation and skate park feature called Semblance. Semblance is a skatable sculpture, and it's constructed by the Bill for Bokuma. It recreates different skateboard street spots from Barcelona, New York, and Toronto. And there was a festival that was organized around these sculptures. So we also had like youth workshops. We had like an opening activation. Yeah. So a lot of these different activities are trying to figure out ways to include the community in the, or to change the skate park design process to include a co-design element or to include community involvement. So we're in the midst of trying to advance this model. And then the last thing that I'm going to show you is a project that we've just started, which is called Visualizing Ipperwash. So through the lab, we've been supporting projects that are aligned with our mandate. Monica Virtue is an adjunct researcher. Virtue's practice takes the form of digital interactive documentary projects. She's been mapping the concerning tensions, histories, and political conflict in Ipperwash for the last 16 years. Her most recent work is with the family of slain activist Dudley George. And the Ipperwash Park Film Project incorporates multiple storylines, including First Nations land surrenders on both ends of Ipperwash Beach in Caledonia, and a number of significant surrenders in Sarnia's Chemical Valley. Monica has also conducted a thorough investigation into hundreds of inquiry audio exhibits, tracked down experts in Indigenous histories, and sourced stock footage and still photos from archives across North America. The project ended up lasting 7 years with primary research concluding in 2012. So her most recent work involves oral testimonies from an indigenous elder, David Plain. She's adopting a transmedia storytelling structure for this work using drone videography and 360 video to outline treaty territories accompanied by oral histories. Yeah, so we're in the lab, we're just working away, trying to use drone videography and photogrammetry and these types of digital technologies to figure out how to create these forms of community engagement, but also public dialogue. Specifically, like, I'm heavily involved with the advancement of the Toronto skateboard strategy plan, because I've been skating for like over 20 years, and it's something that's really close to me. But we're seeing a lot of change in terms of how can we include community involvement in the designing of skate parks, in the building of skate parks, and yeah. So that's it. Thank you for listening.
So, Giovanni, I think maybe I can ask you to join Immony at the front again, and we'll just commence with some conversations. Fiona, can you hear me?
Thank you for listening.
Hi, Fiona.
Hi, I've knocked it off, Fiona.
Were you able to hear Immony's presentation, Fiona?
Yes, I heard it. Yeah.
Awesome.
Fine.
Awesome. So, thank you for 3 excellent presentations. Maybe we share a microphone with Giovanni. Thank you. It's really amazing to see the work that the 3 of you are doing and how that's addressing different scales. Maybe I think each of you have kind of touched on the culture of technology a little bit, and I know that featured heavily in our first Skype conversation, Giovanni. So I'm curious if each of you could briefly respond to how you think about the culture of technology. I know Carlo Ratti's associates is very intentional about how they craft the culture of technology. Fiona, I know that your role within Connect is specifically to provide a kind of critical voice with research engineers. So I imagine that involves thinking about the cultural, the social, the political implications of the things that are being imagined and invented. And then Immony, obviously your work is so intimately tied into really specific cultures that are historically situated, geographically situated, and also kind of subcultural in regards to skating. So could each of you please just maybe address how you think about the culture of technology and how you try to work with that?
Yeah, thank you for the question. I like it very much because I'm very passionate about that. You know, I mean, if I should summarize what we do as Carlo Ratti Associati, we do culture of technology in the sense that we don't do technological development, okay? What did you see in my project? It's really the result of the integration of a number of existing technologies, of off-shelf technology. Okay? We didn't invent LiDAR or drones or... but we had the mindset to understand through aggregating existing technology how we can create a value on top of that that is really able to impact on the life of people. So our goal is very much to change the way we work, we live, we interact, and especially our goal is very much to simplify the way we live with technology. My impression is that technology, in a way, complicated a lot our lives, but has also the power to simplify and to allow us to concentrate back on our inner emotions and feelings. Once a year, I force myself to go to Pompeii. I'm not sure if you've been, but when you go to Pompeii and you enter the old Roman city, you understand that in the end, we haven't changed much from there. You know, we have overcomplicated things, but in the end, we as humans have the same feeling, the same passions, and our goal as designers is to allow people to focus again on that instead of on complicated, you know, technologies or programming stuffs. That's why, for example, for us, just to conclude, it's like the most important thing as like in managing a company, because I'm the CEO, so I'm very much engaged, like into the management also on the whole organization, not just on the creative side that is more on Carlos, but you know, the most important thing for us is the company culture. Okay, so the first thing is to create a very strong identity, to create and share with the whole team a vision and a methodology. That's why, I mean, it's company like culture of technology and company culture, when you do innovation and design, are very much linked.
Will I go for it, Simon, or?
Please go ahead, Fiona.
Yeah, I mean, I'm going to be probably a little bit more skeptical about the culture of technology, but that's, as you said, kind of my job. And I think kind of working in the context of a technology research center, I guess my job is kind of constantly asked, just because it's technically feasible, what is the type of value that it's adding? So especially in Ireland, everything's focused on you know, all of these technical developments are focused on the economy, what jobs are they bringing, what kind of stimulation to the economy. But I think there's a slight shift now, as in like, what value is it bringing to what are the cultural implications, what are the social implications? But I think it's interesting to think in the context of the work I presented about, you know, the likes of Google, and I know Facebook have kind of abandoned their drone-based infrastructure, or they've parked it for a while. To think about what is the kind of motivation and value system behind this technological development. And I guess I can't, you know, there's aspects of kind of when you're delivering infrastructure to remote areas, there's, you know, Jim Thatcher talks about, the geographer talks about data colonialism. And so I guess I verge a little bit more on the skeptical side.
Maybe just as a brief follow-up, and we'll actually, Immony's apologies, please go.
For me, when I think of the culture that surrounds technology, I think about, I'm just going to speak directly to my experience with working with skaters within the city of Toronto. It's about creating these tactics that allow them to interface with municipal strategy. It's all about building out literacy and agency, being able to create visualizations and contributions that allow, that will actually be implemented in the future. So I do a lot of skate park design and digital literacy workshops with young skaters to get them into 3D modeling, or get them into to engage them with this process of creating visualizations that can be implemented in the future. So thinking about these entry points that we could form by using a democratic approach to technological, to democratize those processes that might be barriers for other communities. So
that makes sense. Yeah.
Sure.
So, is this close enough? Yeah. So I'm asking a technical question to Giovanni about the Paint by Drone project. So he mentioned ultra-wideband telemetry and computer vision. So oh, by the way, I'm a high school student who's very interested in technology. So computer vision, how similar is it to the technology currently used in Tesla Autopilot? how similar is computer vision to the technology currently used in Tesla's autopilot?
Oh wow! I'm not sure I mean, I don't know Tesla technology enough, so I can't really say. Let's say that I can tell you something about the potential of this technology. That the reason why we're also proceeding with this technology is the fact that you can apply to any kind of space. Okay, the ultra-wideband technology has the issue that has to have a number of sensors on the vertical surface itself. So it needs like work on the surface in which you're going to intervene. While the computer vision obviously is a kind of a movable technology that can be easily moved into the city. That's why we're talking with a number of players that are interested in understanding how to use this kind of technology also for maintenance of building. You know, I mean, you could either detect the status of a building or also, you know, repaint or do some kind of treatment to the building itself. In terms of a connection with the technology of Tesla, I can't reply because I don't really know the technology that Tesla is using as a computer vision.
So can you please describe how it works? Like how the computer vision works?
Yeah, there's a system, like it's very simple. There's a series of cameras that are put like afar from the surface. Okay, so about 15 meters from the surface. Okay, and they're able to detect the movement of the drone on the surface itself. That's why I say that it's kind of, you know, a plug and play technology, because once you locate it in front of the surface and it maps the surface, then it's very easy to set up.
So it's similar to a mouse, you know, the laser scanner on the underside of the mouse?
No, it's similar to camera recognition, you know. So you analyze the image of the camera. So it's not like a mouse. It's like camera recognition. In this sense, I guess that it's similar to the technologies that you use for Tesla. Although, for example, in the other project that I showed you, in which we're talking about self-driving, in that case, for example, we're using LiDAR, which is way more accurate in detecting objects. Or sure.
Hi. Whoa, that's loud. I have a question about these projects. I think everything that you've talked about is super fascinating, but as designers or as, you know, project organizers in these kind of design and art spaces, to what extent are you considering the kind of data collection, privacy implications, the surveillance implications of using drones in public spaces? And you can answer that maybe on a personal level or on a more pragmatic level.
Yeah, I'll do both. So on a more pragmatic level, the three projects that I showed you, they don't actually collect personal data. You know, they mostly collect data about the functioning of the city. And this is very much part of our research, understanding how through data collection we can have a different insight of the city as a living environment, you know, as a living object. In terms of personal answer, I think my idea when we deal with personal data, I think that if I think about the future in 50, 100 years, I believe that as it is happening now, things will become more and more transparent. So I don't think there will be a moment in which we ourselves will be able to really protect our data. And so I envision a society in the future in which everyone will be able to know everything about all the other people, you know? I mean, I imagine a future in which we will have a full transparency that will destroy the concept of privacy. And this will be obviously a game changer in the way we relate with other people. Obviously, we don't know the real impact of this, but I'm sure that could be also positive impacts on this, or most of them could be positive.
Fiona or Immony, do you have anything that you would want to add to that question?
You go for Immony. I'm disturbed by that idea that privacy will disappear.
I mean, Immony, when you showed the video of capturing the neighbor's backyard, there's a kind of invasion happening there. So maybe that's a small moment to ground a response.
Yeah, there's totally there is an invasion of privacy. Yes, but within an arts context, I don't want to ever harm people with the type of work that I put out there. I really aim to create work that allows people to have positive outcomes culturally, socially, politically. So like with skate park work, I'm always ensuring that we have everyone's consent when we do data collection, when we do public polling, when we do design competitions or workshops. We always have the community and the public's interest in mind, because that's our social responsibility.
Fiona, do you have anything to add to this question? If not, there is another question lined up.
Yeah, I guess just, I mean, it's one thing. It's one thing to talk about data collection in terms of non-human data collection. I think this was a really powerful thing. So one of the things that we're trying to do is to map and kind of create an asset register of all the individual kind of street furniture components in a city. And I think in terms of collecting that type of data, it's really powerful. But I guess I'd still be pretty old school in terms of ideas of privacy and how important that is.
In 2014, I was working as part of a group, and we did a project called City of Total Awareness. And it was kind of, I guess Snowden had just, that story was still fresh. And it was this kind of funny idea of what if everyone knew everyone else's business? What if there was like a Twitter that gave you the capacity of the CIA, and then there was just this mass visibility? And the project had two pieces to it. One was a large-scale map of Toronto that emphasized the communication infrastructure and tried to show where that communication was traveling. What are the grammar of devices that constitute our relationships within this mass transparency? And then the second part of it was just these very short 6-second vignettes of different spaces in Toronto with a kind of diagrammatic overlay that started to talk about the kind of relationships and intentions that people would have. So it was a very inconclusive project, but it's definitely a provocative idea to think about what happens if just even the concept of privacy just dies. And for myself, that's not a happy thing, because I think it opens up us to a lot of techniques of management, which I think was a really a keyword around the NES Smart Highway project that I heard, and also present in the Facebook proposal that you were showing as well, Fiona. But maybe I'm going to bracket that conversation off, and we have another question.
Thank you. This question is for you, Giovanni. Just if you could clarify a little bit what you said about the project in Amsterdam. So you say that Amsterdam was the perfect ground to actually test that. And my second question basically was to know if, at this point, you mentioned that it's autonomous. So you're going to be transporting people. So from the safety side of things, is it any way you can override the drone as it's going in that environment?
Yeah, thank you for your question. Yeah, so the project started in Amsterdam, and I mean, it was pretty straightforward to think about water as a tool to improve mobility in the city, because there is, as I was saying during the presentation, in a city like that, you can't really create new other ways or tools. I mean, you can create new streets. This is actually a problem in many cities. So I can tell you, for example, what happened in New York. with a similar project. So New York doesn't have canals, so we have to invent something else. And in that case, for example, we try to understand how we can improve, for example, the taxi service. You know, the mobility in Manhattan is collapsing, so you have to and people, and more people is moving into Manhattan. So you have to understand how can I offer an improved level of services without incrementing the infrastructure. And we started studying data about all the taxi in Manhattan, and we understood that half of the time a taxi is in what we call a lead situation. It means that it's traveling without the passenger. I mean, it's just between a trip and the other, the taxi driver drives around without people on the taxi just to find the next passengers. So we said, why don't we try to understand what happens if we apply a system like Uber to the taxi in New York? It means that you create a digital platform for booking the ride so that you can, as soon as you drop off a person, you can pick up the next one a few meters away. And the research that went to Nature also showed that if we, applying a strategy like this one, we could reduce the number of taxi of 40%, or keeping the same number of taxi, offering 40% more trips. And this is a game changer. In a sense, was like understanding how we can optimize the existing infrastructure in cities, in existing cities. The second question, sorry, was about.
Well, you say it's autonomous. The drones on the underwater are autonomous, so they will be transporting people. So, is there any way you can override that in case of an emergency?
It's a good question. I mean, let's say, obviously being self-driving vehicles and having a number of security technology embedded, if something happens, we know in real time, we can get the information in real time and intervene as soon as possible, which is different, for example, from normal cars or like an accident in the street, you have to call someone and blah, blah. So we haven't reached this level of studies, but obviously when you deal with self-driving vehicles and with artificial intelligence, you can easily program, a number of actions that follow a specific event, such as an accident or something like that.
Okay, we have another question, and this will be the last question.
Hi, I have a question for Fiona. Regarding the projects you talked about, what are the health benefits or health impacts on some of the projects you talked about, especially with the dawn of 5G expansion in modern cities? How does that work?
You mean in terms of radiation?
Yeah, radiation, the frequency waves concentrated in all those cities.
I have no idea. I really don't know whether it's like the kind of realm of what's the word? People who are kind of scared of everything, and it's really not my area, and I'm really not a technical person. It's not something I look at all. I guess people have concerns. I mean, apart from radiation, people have concerns about the amount of equipment that they propose will kind of be introduced, especially when you look at new generations like 5G, the oncoming of 5G. I mean, there's some prediction that you would need a small cell every square meter for certain densities of users. So, I mean, that's really immense. And I think it's something that is not going to go, I think in terms of the amount of equipment, I think it's something that's going to become much more, it will become much more of an issue, and you already have people kind of protesting the installation of small cell, and they can be done in a very, I've seen, US postal transfer style boxes that are masquerading as small cells, so it's kind of, there's this kind of trickery going on, I guess, to kind of disguise them. But I'm sorry, I'm really not sure about radiation.
Fair enough.
Yeah. unless somebody else, maybe Giovanni or anybody know? We don't. Sorry.
So it is 1:30. I guess lunch was supposed to begin at 1, but I guess we can just push the afternoon sessions a little bit. Can I propose that we come back for 2:15? It'll be a little bit of a shorter break. We'll start with the panel staging the apparatus, which will feature Elle Flanders of Public Studio, chaired by Scott Sorley, as well as feature Hilary Mushkin from LA. Following that, we will hear from Kira Bracken-Rausch, who asked the privacy question, so we'll get kind of her thoughts and response to that. It also features Ala Rushan, who, if you were provoked by the LiDAR images of the city, machine vision is one of her significant research interests. And we'll also have Sam Seward joining us from Prescott, Arizona. Following that, maybe a little bit later than 4:30 will be Liam Young's performance lecture, I Spy with My Machine Eye, which is offering a kind of history and future of the drone. And then we'll have a concluding conversation. I think there's maybe more questions in the room. I know that I'm starting to have some forming around a new grammar of objects within the city from all three of your presentations. But I think that we'll get to continue to think about that and